We're going to continue talking about functions. We're going to talk about just fundamentally what is a function. And a function is defined to be a rule that assigns to each element, each input value, we'll call it x in the domain, exactly one output value that we'll call the range. Here it calls it set b in the function f of x. So we need a rule to show us what manipulation is going to happen on the input value, x, in order to give us the corresponding output value, y. And those x and y values are what gets graphed in the plane that gives us the graph of our function. So we read the symbol f of x as f of x. It's called the value of f at x. The domain of the function is all the values that we put into the function that will give us a real number output. The range of the function is the set of all those values that come out of the function after performing the rule on the input value. The input value, the x values for us most of the time, it doesn't have to be the variable x, but most of the time it is the independent variable. It does not depend on anything else. We pick the x values, we put them in the function f of x, we perform whatever operation that is on the domain value, and that leads us to a range value or a y that is dependent on the value of x that we put in. That's why the y value or the range value is the dependent variable. So I like to talk about functions as machines. We have input values that we put into the function machine. Some value we'll call x that we go and get out of the domain. So the domain is all of those input values that we can put into this function machine. The function does some manipulation on that input value. Let's say f of x is x squared. So for every x that we put in this particular function machine, it takes whatever we feed it and squares it. That is the mathematical operation that is done on the domain value that we put in there. When that is done, we get a corresponding output value. That's the whole range. That's the set of numbers that are the result of this mathematical operation done by the function f. So we have input values or domain values that lead to output values or y values that come from the domain and map us to the range. So we know that we have all of those values to keep up with. So we think of the domain as all the possible input values that we can put into this function, and the range is all the possible outputs. So we have this domain, here they call it set A, and it's all of the input values that we're going to put into this function f for whatever the manipulation is. It doesn't matter what it is. And it will lead us to corresponding output values. So that's just simple domain and range. The only trouble we get into with domain is that we have to worry about if we're dividing by 0, or we have to worry about if we're going to get a negative under a root sign, under an even root sign. So domain is pretty easy for us to find. Right now, just in basic algebra, range is a little tougher to find. So we'll have to use some other techniques that we know in order to work out our range values. But domain's pretty straightforward. So let's take this function f of x. F of x equals x squared plus 4. So this function says whatever I feed it, whatever value I feed it, I'm going to take that value and square it, and then I'm going to add 4 to it. And that's going to lead me to my domain values that we call y. So there was pretty much expressing it in words. If we want to evaluate this function at f of 3, then we have 3 squared plus 4, or 9 plus 4, which is 13. To evaluate this function at negative 2, we're going to take negative 2 and square it and add 4. So that's 4 plus 4, or 8. If we want to evaluate this function at the square roots of 5, we can evaluate functions at any real number value. So we're going to take square roots of 5 and square it, and add 4 to it, and that will give us 9. Now let's go back and let's talk about the domain of this function. When we're dealing with domain, all we have to look at and all we have to ask ourselves is, for what value would I get into mathematical trouble for some value of x if I put it in this function? The only things we have to worry about are division by 0 or a negative under an even root. Those are really the only things we look for. So in domain, we look for, and let's write this down, in domain, we look for values that we can't include. That's the easiest way to find your domain. If you can't look at a function and say, well, if I put, x equal 2 in there, then I'm going to have division by 0. If I put x equal 4 in there, then I'm going to have a negative under that even root sign. Here we see for this function, x squared plus 4, there's no real number value that we can't square. And we won't run into any mathematical trouble squaring any real number. And then adding 4 to that result's not going to be a problem. So the domain for this function is going to wind up being all real numbers. And remember, we write that as open parentheses negative infinity to positive infinity. So there's the domain for this function. Range is a little bit different. Range right now for us is going to be easier to find if we look for the graph. If we can look at the graph of a function, that's going to be the easiest way for us to find its range. It turns out that if we could use calculus, range is extremely easy to find. But just using algebra, we have some issues when it comes to range. So let's graph this function. We know that this is the parent function x squared that opens up, and it's been translated 4 units to the north or up along the y-axis. So this function is going to look like this in the plane. It's just a parabola that opens up. So graphically, it's very easy for us to look along the y-axis and see what our range is going to be. And all of the outputs of this function are going to start at positive 4, and that's included because that's our vertex point, and they're going to go to positive infinity. So for now, graphing our functions is going to be the easiest way for us to find the range. So evaluating functions is nothing more than looking to see what is being put into our function rule. And we could have f of t, there's no problem with that. We can have f of s. We could even have f of y. We usually use y as a range value, but we don't have to. We could have y as the range value, y squared plus 4, and we could call our output values x values. It doesn't matter. It's just we've always chosen, when we teach you about the Cartesian coordinate plane, we've taught you the horizontal axis is x, the vertical axis is y, so that's what we're comfortable with. So we'll say this is f of x, and that says that we are going to square our input value, multiply it by 3, add our input value again, and then subtract 5. So if we were to evaluate this at some input value other than x, then we know that that's what's going to be going on with this function. So let's use this function, same function, and evaluate it at each of these values. So for a, we have f of negative 2 is 3 times negative 2 squared plus negative 2 minus 5. So we have 3 times 4, which is 12, minus 7. So the output value here would be, is that 5? Yeah. So this would give us this point in the coordinate plane where x is negative 2, y has to be positive 5. So let's find f of 0. When we plug 0 into this function, everywhere there's an x, we plug in a 0, and we find that that's just negative 5. So the number we would graph here, or the point we would graph in the plane here, looks like that. And then we can go ahead and quickly do C and D. I know you all know how to do this, but I just want to lead you into our function discussion because the whole function machine thing helps us when we start talking about function compositions and all those kinds of things. So we're going to add 4, we're going to subtract 5, 3 times 16, whatever that is. You know I can't add, subtract, multiply, and divide. So there's going to see 30 and 18, 48 minus 5, so 43. And then D, that's C. D would be f of 1/2. So we would take 3 times the quantity 1/2 squared plus 1/2 minus 5. And so we're going to get 3/4 minus, this is 10/2 minus 1/2 would leave us 9/2. We find a common denominator, 3/4 minus 18/4 will give us a negative 15/4. Is that right? So you get the idea. It's just a matter of plugging in that value. All right, so here we have a graph, and we can find inputs and outputs on a graph just as well as we can find it given a function rule. So here is a function t that gives the temperature between noon and 6 p.m. at a certain weather station. Now, some things I want to point out to you. Here is the independent variable. So if I was going to write this in function notation, this is the function t of x. And whatever input value I put in there, let's say t of 1, then I can go to that input value, go up to the actual surface of the graph, and find what the output value was. So that output value is going to be 25. So here it says find t of 1, t of 3, and t of 5. So we want t of 3, and we want t of 5. And we can easily do that just by looking at the graph. T of 3 is 30, and T of 5 is 20. So not difficult to do. We know our way around a graph. Which is larger, T of 2 or T of 4? Well, here's T of 2. That's the output value. There's T of 4. So T of 2 gives us the larger value. Find the values of x for which t of x equals 25. Well, here's 25 right here, this line. So there's 25. We already found out that t of 1 was 25, but t of 4 is also 25. Find the values of x for which t of x is greater than 25. That happens on this entire interval right here, on the interval from 1 to 4. The output values on this function are 25 or greater. Let's talk really quickly about average rate of change. Average rate of change is the change in the function over 2 points. We want to know the rate of change, the average rate of change over a time interval or over an input interval. So if you drive a distance of 120 miles in 2 hours, then your average speed or average rate of travel, average rate of change of distance, is the amount traveled over the time it took to get there. That's where we get miles per hour, right? Your units help you recognize that you're dealing with a rate of change. Average, the average rate of change is that we need 2 points. 2 points of reference, 2 points of data in order to compare over that time interval or over that independent variable interval what happened on those 2 points. It's different than instantaneous rate of change. We're talking average rate of change. So let's look here. If we were to graph what was happening, sorry, it's jumping around on me. If we were to graph what was happening here, starting at our time interval of 1 hour and stopping at our time interval of 4 hours, then the rate of change, the average, we do need to say average, about out of time. Look for the next video.